So today we will go through the midpoint theorem in quadrilaterals. It says that the line segment joining the midpoints of two sides of a triangle is parallel to the third side and is half of it. So let us draw a triangle. So ABC is a triangle. This is the line segment joining the midpoints of AB and AC. So this is equal to this and this is equal to this. So it is given that E and F are the midpoints of AB and AC respectively. So what we need to prove? We need to prove that the line segment joining the midpoints of two sides. Midpoint of two sides of a triangle is parallel to the third side and is half of it. So we need to prove that EF will be parallel to BC and EF will be half of BC. So to prove, we need to go for a construction. Let us draw a line CD. Let us draw a line CD parallel to AB. So let us draw CD. Draw CD parallel to AB, and we extend EF to join D. So extend EF up to D. Now what we get? We get two triangles. So in triangle AEF and triangle CFD. So AEF and CFD. What we get? So this is parallel to this. So this angle will be equal to this angle. Alternate interior angles. We get this side equal to this side as F is the midpoint, and we get this angle is equal to this angle, vertically opposite angle. So let us name it as 1, 2, 3 and 4. So in triangle AEF and triangle CFD, what we get? Angle 1 is equal to angle 3. Why? Alternate interior angles. Then AF is equal to FC. AF is equal to FC. AF is equal to FC. Why? AF is equal to FC because F is the midpoint. It was given to us. Now angle 2 is equal to angle 4. Vertically opposite angles. So which implies triangle AEF is congruent to triangle CFD by angle side angle congruency. Now what we get? So which implies AE is equal to CD corresponding parts of congruent triangles, and we get EF is equal to FD corresponding parts of congruent triangles. So we have made this triangle congruent to this triangle. So in CPCT what we got, AE is equal to CD and CF is equal to FD. Now A now AE is equal to BE because E was the center of AB. So what we write? But AE is equal to BE, which implies then BE will be equal to CD because AE equal to CD. So we get BE is equal to CD. Also, we get BE is parallel to CD because AB was parallel to CD. So what we get for quadrilateral BCDE, BE is equal to CD now and BE is parallel to CD. So one pair of opposite sides are equal and parallel, therefore BE DC will be a parallelogram, which implies BCDE is a parallelogram. Why? Because one pair of opposite sides are equal and parallel. Now since we have proved BCD is a parallelogram, this implies EF is parallel to BC, which implies EF is parallel to BC. This was required in the proof. EF is parallel to BC. Now we have to prove EF is half of BC. So why EF is half of BC? So since BCD is a parallelogram, so ED will be equal to BC because opposite sides of parallelogram are equal. Now we have proved earlier we have proved that EF is equal to FD. EF is equal to FD. So we can write ED as twice of EF. So we can write ED as twice of EF, which is equal to BC, which implies EF is equal to half of BC. So it is proved. So what we did, let us have a quick review. So what we did, first we draw a line parallel to AB. Then we joined D to F. We get two triangles. We made it congruent by A as congruency. In CPCT, what we did, we needed to make EF parallel to BC. So what we take it as clue that let us prove BCDE as a parallelogram. Then this will be parallel to this, and when this side will be equal to this side, so I will make this as half of this. So what we did, first we made that this, already we in construction we have taken that this is parallel to this, AB is parallel to CD. Only what we needed to do is that we need to prove somehow BE is equal to CD. So then if we prove BE equal to CD, BE is already parallel to CD. We will get BEDC as a parallelogram. For that, what we did, we by making triangle AEF and triangle CDF congruent, we got AE is equal to CD. Now AE was equal to BE and AE is equal to CD. Therefore, BE will be equal to CD, and BE was already parallel to CD. Therefore, BECD became a parallelogram. One pair of opposite sides are equal and parallel. Therefore, we get EF is parallel to BC and ED is equal to BC. But since this triangle was congruent to this triangle, therefore this side was equal to this side. So we can write ED as twice of EF, which is equal to BC. So EF is equal to half of BC. Hence we proved the theorem.